Hello everyone. Welcome to yet another live stream from Hack This Fall, and I would say this is the last one that we'll be hosting for this particular season. But I'm quite excited to conclude this on a really good topic, which is getting started with microservices architecture and conductor. And it is a workshop conducted by Saksham Solanki, and he's joining us from Ocus, who is also our powered by sponsor. He's working as a software engineer there, and it's going to be fun knowing more about all these microservices architecture, how you can leverage that in your hackathon projects at Hack This Fall, or maybe at other hackathons you're participating in as well. But yeah, quite looking forward to that. I would also take this opportunity to welcome everyone in the chat who are joining in. Feel free to say hello, hi's in the chat. Let us know where you are joining in from, and would love to know more about you there as well. And remember, you can always ask questions whenever you feel like you are stuck somewhere or you have any queries related to a specific topic of discussion, and they will be more than happy to help you out over there. But without further ado, let me quickly invite Saksham over onto the stage so that he can walk us through everything Orcus, what's in store for you all, and yeah, a lot many other things. So, hello Saksham, welcome.
Hey Siddharth, thank you for
How are you?
inviting me. I'm good. How about you?
All good, all good. I think
All good.
we can get started with your session. Let me know once you are on your slides and I can bring up your screen.
Cool then. Okay. Hey folks. So my name is Saksham and I am working as a software engineer with Orcus. And today I am here to present the session on a workshop on getting started with microservices architecture and deep dive into the conductor. So yeah, without further delay, I think we can probably start our session.
Yeah, awesome.
So I can share my screen. Uh, I think it's visible. Let me know if it is.
Yes, it is visible to all the audiences. Well, you can turn the full screen. Perfect. All the best.
Cool. So, hello, folks. So, this session is all about getting started with microservices architecture and conductor. So, my name is Saksham, and I am a software development engineer at Orcus, as you can see. So, let's move to the next slide. So I am a Saksham and I'm working with the Orcus. I am working with everything at Orcus, like it's related to even cloud infrastructure, DevOps, uh, core conductor, AWS GCP, and kind of event-driven microservices architecture, everything. Also, I am a core open source contributor in the Netflix conductor, which is I think deprecated right now, and the new home for that Netflix conductor is the conductor OSS, where I am regularly contributing. So you can check it, and if you like to contribute more in our conductor, would like to know about more about the conductor community and all, you can probably follow this link basically, and sorry, and you can uh, make your first contribution here. And yeah, make sure to like this repo star. I mean, make sure to star this repo so that we can build. And yeah, I will tell you about this, what is this play.orcus.io in the last. So I will go next. So yeah, this is the table of content for today's agenda. So we will look into the these topics. As I already told that I will tell you about this play.orcus.io. So I have included this link in the last section, right? So I can go with the evolution of application architecture, what is conductor, what is monolithic versus microservices architecture, right? And I will give you an example on that. I will explain you regarding the difference between orchestration and choreography. This is the terminologies which is widely used in the microservices world, right? And the fifth topic will be the orchestration platform, which is basically the conductor. So yeah, I will take the doubts in between. I will be having a very small activity on this platform, which is play.orcus.io, which is nothing but a playground to play with the uh, workflows for microservices orchestration, right? I will go dive deeper into this after this slide, right? So yeah, we can start with the first topic, which is evolution of micro application architectures. So yeah, it has several components. So what used to happen, uh, like let's say 10 years back from now, right? We used to have uh, computers, right? A big data kind of computers which can store like very vast data. Uh, then we had client server architecture, right, which came after some years. Then we built websites on the top of that, right? Then we started building the enterprise application, servers, WebSockets, and whatnot, right? Then we started working on the event-driven apps like example messaging queues, this Kafka. Then we can say RabbitMQ, AWS SQS, and whatnot. Then we came into this concept of distributed systems where the we started deploying the various different services into different clouds, and that's what we started calling that as a microservices, right? So microservices has its own advantage and all. So we will discuss what is the bottleneck and advantages of both monolithic versus microservices architecture in the next slide probably. So uh, yeah, I think we can go over the next slide. Okay, so what's the difference between monolithic versus microservices architecture? In the monolithic architecture, we have a system, and there is a these are the components inside that system. UI component, business logic, which is kind of your server, and data access layer. You can say is a database and all, and everything resides in a single component, right? So, what's the uh, disadvantage of monolithic architecture? Can anyone tell me in the comment why we came into microservices architecture? You can Google it out as well. Not sorry, or even I can go. Okay, no worries. I can go. So, uh, in the monolithic architecture, we had a disadvantage. That is, if what if our data center or database fails or crashes? What if uh, the machine where we are storing our data got, you know, fired up, or it got uh, damaged due to raining and all? Then our entire application will be gone, right? So yeah, correct. Single point of failure. So single point of failure is a big thing, and there are many companies in the world, right? Like let's say example of Netflix, right? So Netflix has so much of data, right? If they will rely on this monolithic architecture, then everything will be gone. If there is a single point of failure, right? So because of this, we had a concept of uh, microservices architecture. So we will deploy. So in the current world, we had a facility to use cloud as a service. So we deployed our applications. Let's say there are different services for each use cases. We deploy each service to to our cloud, right? And each service can have their own databases. So what is the advantage of this microservice architecture? If a single service has gone, right, it is a replica set, what we call as a replica of this service. It will automatically you know spin up, or I can say spawn up the another service, right? So in that case there is a chance of 100% availability, right? So what is the disadvantage then? The disadvantage is it could be an expensive thing, right? Since we are deploying and asking cloud providers to uh, put our services on their platform, right? There could be thousands of microservices. In this example, there is only 6 one. So this could be an expensive thing, right? So yeah, that's all about this slide. I can go to next one. So this is the example of microservices architecture. uh, you have a mobile or web application. You request something. For example, you are clicking some buttons over your mobile and you are requesting for something through the internet. Then this will go through the API gateway. API gateway is, you can consider this as a central point, right? Centralized. Uh, then there could be a different microservice for their individual use cases, right? For example, catalog can have their own use case. It could have its own DB, right? There could be a shopping cart service. There could be a login registration service. There could be a discount service, ordering service, and whatnot. So these all are kind of different microservice for a single application, right? And how these are connecting? These are getting connected with the example of messaging queues. So messaging queues is nothing but each service put their messages in a queue and other service consume it. So that's how both multiple microservices interconnect with each other. And this is the standard example of choreography. I will explain what is choreography in the next slide. So I can go and explain what is the difference between the choreography versus the orchestration. But any doubts still here, let me know in the comment section. I am parallelly checking the uh, chat as well. Let me know. Okay, so a quiz for all folks. How many microservices and users Netflix have in current time? Can anyone answer? Let me know in the comment section. If no, I can go ahead. Uh, okay, I will tell you the answer of this. So Netflix has thousand more than or even more than thousands of microservices, right? And the current user base of Netflix is around 240 million, right? So how does Netflix handle all this, you know, load on their servers and all? So Netflix uses the microservices architecture, right? And that's how they manage the load of on their servers and all using this distributed system technology, which is we call as conductor. I will explain about the conductor in the next slides. But yeah, this is all about this quiz. Okay, so this is the example of difference between the orchestration versus choreography. So orchestration, what is orchestration and what is choreography? So orchestration has, so this has a centralized server, which is known as, we call as conductor. So this circular, I mean the central one, this is something known as conductor, and these are the microservices. So how these microservices interconnect with each other, right? So this conductor helps intercommunicating each microservice with each other, right? For example, if this microservice wants to send some message to this one, so conductor will help this, right? And this is choreography. In the choreography, if these microservice want to connect with this one, right? Then we have messaging queues, which we known as event brokers. This broker will do, this microservice will publish a message in the queue, right? And this will consume it, and it will process it. It's what is it is going to do with the input of this microservice, right? So what is the advantage and disadvantage of both of this, right? So in the choreography, first I will talk about the disadvantage of choreography. So choreography, since it has it works on the messaging queue, right? So what if we are using thousands of microservice, and the load on the messaging queue, let's say there are lakhs of messages in the messaging queue, then what? So in that case, it could be happen that another microservice is not able to consume, right, at the time, right? There could be a delay, right, because messages could be too much, and even the queue could be overflow, right? So this could be a disadvantage. uh, there could be a delay when consuming the messages, right? And what could be the disadvantage for orchestration? There could be, this is the central server, right? If this is gone, then everything will be gone. There could be single point of failure, right? But to avoid this, we use the replica sets. We can deploy this in the cloud, and we can use the concept of replica sets, right? So if one of the uh, so what does it mean by replica sets? So we use the replicas of this server. I mean, we can use maximum three servers, right? If one server is gone, then another will come up. So so we can, provide the availability by using the cloud, right? So that's the advantage of orchestration, and that's what Netflix uses uh, in current time, and many companies uses this orchestration technology, right? uh, yeah, so I can go to the next slide. You okay? So what is Conductor? So Conductor is basically the orchestration platform which I was mentioning here, right? So Conductor built at Netflix, developed by Netflix peoples, right? And now Conductor is maintained by Orcus team, Orcus engineers, right? We have also have this open source version of Conductor, which is being used by many big tech companies like Swiggy, Tesla, Twilio, and other, right? Many big tech startups as well. So to communicate with each other and use the concept of distributed system to manage loads. Uh, these big tech companies are using this, uh, OSS Conductor, right? We have an enterprise version as well at Orcus, where we provide the cloud solutions to deploy the conductor and the workers to the different clouds, AWS, Azure, or GCP, right? So if you want to contribute any feature, anything to this conductor, open source conductor, you can go check out this link and create your first pull request there, right? Uh, and yeah, we can go to the next slide. So, what is the benefit of orchestration? Okay, so what is the this term orchestration? So, orchestration is the process. Let me give you an example. So, you go to the orchestra, right? You have seen that there is a guy who plays violin, right? There is a guy who manage and give orders and signals to peoples who play violin along with him, that okay, you have to play this tone and all, right? So that guy, we call that guy as conductor, right? So that's the same thing which we follow in the microservices world, which is there is a single man who handles who helps intercommunicating with each other, each microservice, right? So that's the term which referred from the orchestration. So the first point is centralized control, just like a conductor in orchestra, right? That's what I have mentioned right now. Second point is it is easy to maintain central control service to take control interaction between microservice, right? The conductor will take care of the intercommunication between each microservice and handle state, right? Troubleshooting and logs tracking. So in very complex system, let's say the example of Netflix, thousands of microservices are there. What if I want to track there is some error in my system, some big sensitive error in my system? How will I track this? So in that case, Conductor will help to track logs and states of your different microservice, what it is behaving, what are the logs, what could be the error and whatnot, right? So in that case, the conductor could help you to debug your applications, you know, a very complex application in a simplest manner, right? So yeah, that's all about orchestration. I can go to the next slide. You can join our conductor meetups. We our team at Orcus, arrange and arranges the in-person and virtual meetups. Uh, the in-person meetups happens at different places all around the world, India as well as outside of India as well, right? You can check out this events page where we uh, uh, organize different hackathons, tech talks, sessions, and all. You can join our Slack community as well, where you can check what's going in the OSS version of Conductor, and you can uh, help us. I mean, you can help our conductor team, conductor framework to grow, right? So yeah, that's the thing. This could be the resources for learning. I know like there will be a hackathon, so you will be curious like we can how we will learn about all this and all these things. So these are some examples and docs and blogs which our team has posted on social media. You can follow this and you know uh, use this to create your applications, build uh, scalable microservices, right? So yeah, this is the resources. Okay, this is the interesting part here. So this is the Orcus challenge. So if you use the Orcus in your project during the hackathon, and if you run the workflow on pay.orcus.io, I will show this next right after this. But if you run this on the your workflow on this pay.orcus.io, and you can use programming language of your choice, then we will distribute prizes to three teams, and these are the prizes for different teams, right? So yeah, that's the interesting thing. So yeah, you can use the AUKUS and this playground to learn more about the microservices and conductor architecture, right? Uh, let's go on next slide. Okay, I think I'm done with this. So yeah, that's all about the theoretical part. Uh, I think I can go next and we can play around with the playground, right? Creating our first workflow or and how to run that workflow and all, right? So yeah, I will close this and I will go to the play.orcus.io. Okay, this is the playground which you can use. I will log in here and okay, we are good. Okay, so what is this all about? You can build your distributed workflows here, right? And I will tell you how to run this workflow, what this workflow is all about, what are workers and all, right? So without wasting much much time, I will go to the defined workflow section. I have created a workflow already. I will try to replicate this again, but with the different name. So I can open. Let me open one more tab for this. So yeah, okay. I will go in the defined workflow section. I will create one workflow. Okay, so what is the use case of this workflow? Use case is, let's say I am creating an application for ATM system design, right? How the backend of ATM machine will work, right? So I will define the workflow for our ATM system, right? So how the software part of ATM machine should work. So I will give very basic example. because ATM machine could be very complex. There could be different things going on in the ATM machine. But let's go with the simple one so that you can understand like what is this workflow and workers thing all about, right? So I will name this as the ADM system, and I already created one 2 days back, so I will name this as V2, right? Version 2, and I can use the same over here, right? Now I will go and start building our workflow. So what would be the first thing? First thing would be user will swipe his card, right? User will swipe his card, and card could be having the number. So what should be the first responsibility of your application? To validate the card number, right? So we will create first task to validate our card. So I can use any task here, by the way, but for simplicity and demo, I will first create an inline task. So what is this inline task all about? So this is nothing but you can use a JavaScript to write some code over here, and it will produce some output, take some input and all. So yeah, it will take the card numbers as input. So I will use the card number here, and I will use some syntax here. Let me change this to string first. I will take this as an input. So you can see like there is some uh, input going on here. So I can take card number as input from my workflow, right? And I can write some JavaScript as well. So here you can see I am using value one. I will go over here in the tab and I will write some JavaScript here. So I will take let card number as the dollar dot card number, whatever I have defined over here. Dollar dot card number, sorry, card number, card number, right? And and I will perform some operations on this card number. So since this is a demo, we are not using any database and all in the JS task. I will hard code some rule over here, like this should be a valid card number and all. So if card number dot length equals to 10, right? And card number, and I am also defining a rule that card number should start with the 9. Then I will consider this as a valid card number. Card dot sorry dot caret. This is nothing but a plain JavaScript. Dot caret 0 should be equals to 9, right? Then I will return. You can return anything, but I will return a string here. So valid card or invalid card. This is the first step for designing our ATM, right? So this is I'm saving this. I will add a few more steps over here, but for now I'm going with the single one for showing like how this thing will work. Okay, fine, perfect. Then what next? I will run this and tell you like what it will return. Run this workflow, uh, ATM system V2. Perfect. And I used one input over there, right? The card number. So I will pass that input from here. So I will pass a wrong input here, right? Let's check. Okay, it's returned something. You can see it's invalid card, right? I will go and write the right number here. 9111 10-digit number. 562134. Whatever. Okay. Oh, sorry. I think it's more than okay, it's 11 digit. Sorry. Some problem here. I will copy and paste the same which I have defined here. I have already created this workflow ADM system. I will go and check the logic. Yeah, I can copy and paste the same logic here. Card number. Okay. Card number dot length equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Should return the valid card. Okay, fine. It's returning that the card is valid, right? So this is the first step. Now I will go and define the other steps as well, right? This is the first step, and in this existing workflow, if you could see, there are few more steps. So second step is the validation of PIN number, right? User will fit the PIN number as well. So what if PIN number is wrong? So I will create one more task here, but I will create this as a switch case to show like what are the different tasks we have in conductor. So it could be any task, but for example, I am going with the switch task. Okay. So let's take the switch task, and if you can see, there are some branches in this switch task. So it is nothing but a if else condition, right? So this is the uh, default case, which is the if part, and this if I add one more branch here, it would be else part, and I can add the condition for the if and else part as well, right? So I will name this task as the pin validation, and I will go as the yeah value param. Let me check what I have done here. Okay, I have written my script over here. Okay, so it's accepting the pin number and the card authentication. You know, the output of this result, whether your card number is valid or not, right? So I will also do the similar thing here. Take this pin and this card authentication type from here. The case, sorry. So there is one more option here. You can define your workflow by using this, the symbol of plus, or you can directly go and copy and paste this code, right? So this with each JSON, there's an array of tasks here, right? So first task is this card authentication. The second one is the spin validation, right? So it's getting completed. I think over here, hmm, probably here. Okay, no worries. I'll add more. Yeah, okay. So input parameters is your pin, and it would be your again the same syntax workflow dot input dot pin. Fine. Also, I will take the card authentication output here, right? This why this is important because I will also validate if this worker has failed. I mean, this is returning the card is invalid. Then there is uh, you know, uh, no point to go ahead. We will directly close our application here. That's what I think ATM also do, right? If card or your ATM pin, card number or ATM pin is wrong, then there is no point to go ahead and process the transaction, right? So yeah, I will copy and paste the same here, card authentication output. Now here is the interesting thing. you can use the output of this workflow as the input of this work. Sorry, the output of this task to the input of this task. How I can do that? So I will go workflow dot the reference which I'm using here. This is the ref. This is the important thing here. So dot ref dot output, right? And I think I'm using the result here, right? Result, cool. And the case will be since we are using JavaScript over here, so it would be a case sensitive thing. So I will first copy and paste this. I will explain like what is this JavaScript all about. And here I think we are returning false. Okay, let me explain you quickly. Okay, so here what we are doing is we took the pin from here, dollar dot pin, right? Then we took the card authentication output from here, which is what this is, right? Then uh, we validate. If the card is invalid, then we will return false. If if pin is not a number, this is the function which we used in JavaScript, right? Is nan is something which tells you if it is a number or not a number. So if it is not a number, or if its length is not equal to 4, then will return false, right? Else will return true, correct? So false is the case, and default case is the one which will go in the true side. If it is false, then there is no point going ahead. If it is true, if it is true, then we will move ahead and work on something else. So let's check what is the next thing here. Okay. It will also validate transaction type, whether user want to withdraw or user want to deposit. So I would like to create one more task here, which is basically the validate transaction type. So in the same branch here, you can create one more switch task. You can use any, you know, any number of tasks, any different tasks to create this workflow. But for simplicity, I have already defined this workflow, so I am going with this switch case JS and this simple task based approach, right? So this task named as validate authentication type. Sorry, what was the name? Transaction type. Sorry, and ref is something which is also important as I have already shown. So right, and I will use the ECMAScript over here. You can also use value param, but I am more familiar with the JavaScript, so I generally use this. So if you check the JavaScript of this, I will copy and paste, and I will again explain. And it also has I think two branches. So case is your I will paste the case as well. Invalid transaction type. Switch case is perfect. I think sorry. This is the switch case. Input is I think it is not accepting an input. Okay, so we can delete it. Perfect. I think let me explain this. What is this invalid transaction type? So it will, uh, you know, I think I have missed something. Oh, okay. I think I should add in this transaction type parameter. We will also get this from the input again. Like wants to deposit, wants to withdraw or something. Input dot transaction type. Perfect. Right. Yeah. If it is so, what we have done here, we took this input from the input, and if it is withdraw, then we will return withdraw. Is deposit, then deposit. Else we will return invalid transaction type. Okay, so you can see there is a branch here for invalid transaction type. So if it is invalid transaction type, then we'll do nothing. If it is the default case, I mean any of from this two, then it will go in this branch and we will create one more step over here. Perfect. Any doubts still here, or am I going too much faster? I know we are running ahead of time, but let me know for anything. Okay, I see no comments. Cool, then we can go ahead and build our next step. I think it will be completed in 5 to 10 minutes more. Uh, cool. So we have created till here. I I am hoping that you will be clear on till this step, right? So we can go ahead and create our next step. What if so? Next two steps will be if the transaction type is invalid, right? So what we'll do is we will notify users. Okay, you have you know done selected the wrong method. Although it does not happen in the ATM system, if someone can enter the wrong transaction type because it is already hard coded in the system. But for the sake of explanation and demo, I am creating this invalid transaction type so that I can show you. So yeah, you can see in the false step of both the such cases, there is a send email workflow. I will also do the same. You can use the same send SMS as well or whatever. So yeah, let's create one more task here. So I will use the HTTP task this time, and I will also explain what this task all about. So I will name this as send email failure email failure email. Perfect. I can use any method because what it is going to do is when this task will run, it will hit that API, it will hit that URL, right? And whatever code will be running behind this endpoint, it will invoke that code, right? So I'm assuming like I will use a logic to send SMSs or mails using this endpoint, right? So for mock, I am using this dummy test API. So I have already created this API in the mockable this mockable.io website. This is this is the website where I can prepare the dummy mocks. So yeah, I can use this over here. This will return a dummy response to me. Perfect. And I can change the ref here. I will use the ref one here because we have two uh, same this send mail failure email task. One is over here and one is I will use in this branch, right? So I can save this and confirm. Perfect. We have this in mail mailer setup for invalid transaction type, right? And I will also set up the similar thing for this branch as well, which is I think empty right now. There is nothing, just going directly and getting ended over here. So I will create one more HTTP task here. So I'm hoping like you got the meaning of what is this HTTP task. It will nothing but hit this endpoint behind this URL. So I will again name this as send failure email. So one thing here is you can name the task definition as same, but reference name should be different. Either, else you will get the error while saving this workflow. Uh, okay, perfect. I think uh, okay. We are good till here, and let's use this with the invalid credentials, and then we can go till I mean for the last step, which is I think process this transaction over here. Uh, cool. Then we'll go ahead and copy run workflow. I will also pass the pin because we took the input pin, and pin could be whatever. And there is one more type which I have already added. I think it's just to get execution of this workflow. Copy the input. sorry. Workflow. I copy the same, pass this here, remove some more steps. This is not required right now. I will tell you what is this. Mail is also, I think not required. I'm not sure, but okay. I think okay. Current balance is also not required. Transaction type is required. Okay, these three parameters are the required. So you can see pin number is something which I have, you know, feeding wrong. This should be of length 4, right? So it should go with that send failure email branch, right? So let me try and hit this workflow. Okay, you can see it is going in this send failure email from the pin validation branch directly. It means like your pin is wrong, and you can see the response. Mail sent successfully invalid transaction type or pin. So from where this response is coming, it is coming from this dummy API which I have created over here. You can create your dummy APIs too. That's not a big concern. Cool. I will go and run again, and this time I will use the random transaction type, which is invalid something. So it should go with that branch. Cool. Validate transaction type and send failure email. Perfect. Right. Uh, yeah, that's the case. And now we will. Uh, okay, so I forgot to mention one thing. We should also send the mail from here. But since this is the dummy API, so I'm assuming this will send the workflow to any random mail. So that's not a big case over here. So let's go and create the last step of our workflow, which is process your transaction, whether deposit or withdraw. So here in the default case, after validating your transaction type, I will create one task, which is the simple task, right? So till now we have seen three different tasks. First one was this inline, where you can write JavaScript in your editor itself, this playground itself. You can use the switch case, which is basically nothing but a if else. We have seen the HTTP task as well, which directly invoke your APIs, right? There are more different tasks such as do while tasks, human task as well. But I would not like to go dive deeper into that right now because we are already out of time, and these are some complicated tasks for different use cases. So only explaining about the tasks which could be helpful during our hackathon and all. So I will create one simple task here. Simple task is something which you can probably use in your entire workflow, right? You can replace all the tasks with a single simple task itself and run this workflow. But yeah, that's not a good thing to do. So that's why I haven't done it. We can, if for validation, we can use this kind of task, right? And if we want our, so what does this simple task mean? So if you want to run your code in the server or whatever. For example, I have configured a Spring Boot application on my local, or a Python example, Python application, .NET, Node.js, Clojure, whatever. Then probably you can use these kind of tasks, right? So I will explain you first. Let me create this. I have already created this task here, ATM system, and I named this as process transaction. So I will name this as a process transaction, which is already here, process transaction. Uh, and this process transaction task will take three inputs, which is your current balance of your account, the uh, transaction type, whether you want to deposit or withdraw, right? And the amount which you want to process, whether you want to deposit 5 rupees or you want to withdraw 5 rupees, whatever. So yeah, let's take this inputs one by one. transaction type. Again, I will take this as an input from workflow. Input dot uh, transaction type. Cool. And make sure this should be string, right? If you use different data type over, you can probably hard code your input directly in the workflow itself. I mean, in the task itself. So by using string, I am and using this syntax, I am telling my conductor, the system, that take input from the run workflow, right? Sorry. Uh, okay. I took this input. Now let's take the another input, which is current balance. This all this detail should come with some system and some databases, but for simplicity, I am hard coding this inside this run workflow by passing this static inputs. So don't mind. When we will build the complex system and databases, I will also tell you like how you can use the conductor SDK to run the workflow and with the code and all, and pass this input without passing statically and passing dynamically. So current balance. I hope I am clear till this point. I'm not sure. Amount to process, and this last thing, amount to process. I will copy and paste. Uh, cool. We took three inputs, and what else required in this? I think we are good, and we can save this. You can also change the version, but I'm using the same version over and over again after adding multiple tasks in the same workflow. Perfect. Now I have created this process transaction. How we are going to execute this? Oh, thank you, Siddharth. Yeah. Uh, how we are going to execute the simple task, right? As I have mentioned that this is going to be an application, not something which is directly run inside the conductor application, which we are running right now. This JS task and this switch task and this HTTP. Okay, cool. So I can go and create one simple example in my Spring Boot application. I can use any other technology, but I am more familiar with Java from past few years. I will explain this in the Spring Boot. Okay, I have already configured this. Sorry, I think this application. Uh, you can find this application, or you can use your own. Which is, I think we have already this application, Orcus workers. Uh, or I will tell you like where is this Orcus workers? We have this application in the uh, GitHub. Or if you are not familiar, you can probably go install Gradle, and you can configure the uh, configure your SDK for Orcus and all, right? Then you will have to configure this. So I think I will share the link of this application for the configuration part, and you can probably configure your setup for this writing simple workers for the conductor client. Uh, okay, so what needs to be done after this? We have to use a key ID and a secret. So I will go in the applications. I will generate. I will create one more application. I will name this as ATM design application. Save it, and I will give some permissions. You can read about this. What are these things all about? But we need few permissions to run our simple task. I am uh, turning on all for the sake of simplicity, but this is not advisable. We should only toggle for some of them, not all of them. Then I will go and create access key. Now I will do one more thing. I will copy this key ID. I will go to the application dot properties because this is the Spring Boot application, and I will paste this against this key. There is one key secret. I will copy this and use this over here. Perfect, right? Now, if you use the wrong credential here, your simple tasks won't get executed from the conductor platform, right? So you should use the proper credentials, right? This is the part of configuration. So now let's run this application. This is nothing but your Orcus worker application, and I will go and run this. So you can see in the code it's configuring this key ID secret and all. And in the application properties, there is one more thing. I use this playground API, right? So make sure to use these as well, or else it won't work. So you can see there is no error, right? Now what we will do, we will create the worker for our this. Uh, I will take 5 more minutes. Uh, we are running out of time, but 5 minutes more. So I will create one worker for this uh, process transaction. I will use the same name over here. So let's go and create the process transaction worker. So I have already created this first, but I will remove this logic and recreate this for you. So I have created nothing, but I have created a class here. You can use anything. I have created this class, right? Use component annotation, which is Spring Boot component annotation, right? I will implement this class with the worker, which is the Netflix worker. Perfect. Then I will go and implement few methods which are recommended, task definition name and the execute. So here I will use the same name. Sorry, this name, process transaction. Process transaction. This is the definition. And here in the execute, I will explain you how we'll write the code. So it returns the task result. First, we'll create the object of task result, and that's how we create the object of task result. And here we return it. But before doing that, we will mark this as the uh, okay. So we can, as you have seen, we took some inputs in this task transaction type, current balance, and amount process. So we will fetch this input in this code. So how we are going to do that? So we have a property inside this uh, task object, which is your task dot get input data. It will return the map of your input. The input, these are all inputs in the map form, right? You can take this input one by one. So I will fetch first the uh, sorry, the transaction type. I think, yeah, transaction type, string transaction type, and here input dot get. I hope I am clear till this point. Uh, then again, the second thing is current balance. I will take this as a double current balance, and I will pass this as a double input dot get. Oh, thank you. Uh, so what was the next thing? Current balance. Uh, current balance double. Uh, and amount to process. This could be double. So amount to process. Cool. So I will check if the transaction type is withdraw. Then we will do something. Else, if our transaction type is deposit, you can use any logic here, but I am going with my you know own logic for simplicity. If the transaction type is deposit, then we'll do something, or else we'll do something. So first I will do is I will mark this task. We'll set the status of this task as completed. That means this task is completed. If the transaction type is none other than withdraw and deposit, then we will mark this task as failed because it is a invalid state, terminated. Sorry, failed. Perfect. Right now here, I will do what I will do is I will uh, withdraw. I will reduce the amount from my current balance. So current balance equal to current balance minus amount to process. And here, since I think I yeah, this is correct. Okay. So if someone wants to deposit, then we have to add the money in the current balance. This is just for example purpose. So there are dedicated databases which bank maintains to uh, make the entries for available balance and all different things, right? But this is just an example. So I'm going with this simple program. So I will add this, right? And uh, okay, fine. And also I will do one more thing here. I will update. I can add one more thing in the result dot add output data, which is your new current balance. So I will add a field here, and here I will do the current balance, and here I will also do the current balance. Okay. Also, I can do one more thing. I can add a log. I will tell you what this log is about. Current balance is something. Current balance is balance. Cool. Perfect. Let me rerun this, and this should work now. We will run this workflow finally with the proper inputs. So I will copy and paste the you know correct inputs to this workflow. So I will go and check the execution of our ATM test system and get the appropriate inputs to this workflow. And I will copy this and use here. Okay. So let's check the input first. Amount to process, current balance. That's what I'm using here. Amount to process, current balance, transaction type. PIN is also correct. Uh, Mail is I think not required. Okay, so I'm saying is deposit 200 rupees to my deposit 50 rupees in my current balance. So let's check what happens. I run this workflow going there. And yeah, you can see process transaction is done successfully. I will go to the output and we'll check current balance is 250. Perfect. Logs, I can check current balance is 250, which I have appended over here. Fine. I will go and take example with withdraw as well. Withdraw. So it should return current balance as 150. It's still running. I will go and refresh this. Okay, it's completed. Output is 150, logs is 150. Let's take one more example with the invalid transaction type. But in the invalid transaction type, it will terminate in the previous step. So that no need to worry about that. Yeah, so that's how we can build our workflow, and we can distribute our load in the workflow. For example, I will tell you one more last thing, then we can probably wrap up this session. So you can probably create different simple workflow, and each simple workflow can run on different microservice, right? For example, I want to process my transaction. This can run on system A. if I want to do some operation, some different operation, right? I can create one more microservice and create a task here, right? That can run on different machines. For example, I have ran this process transaction here. I can create two services, one for deposit, one for withdrawal, right? And I can use two different services and create one more task here. And based on that, it uh, either it will process or it will process, right? So that's how we can manage loads between the services. Perfect. There are multiple more tasks there, right? There are joint tasks here, like if you want to perform some parallel execution of 10 tasks at a time, then probably we can use the concept of fork join over here, but this could be a complex thing to explain in this single session. So probably, yeah, that's I think all from my side today. Let me know if you have any doubts or all. Uh, yeah, over to you, Siddharth, if
Awesome.
you are.
Thank you so much, Saksham, for
Yeah,
that
no
wonderful
problem.
workshop. I'm sure, like for everyone watching, feel free to follow along. The recording is always going to be there up on our YouTube. So in case you have missed out on anything, feel free to just find it and check it out. And you still have around 2 weeks before you jump into the hackathon. So just play around with the playground, try to work around with different architecture, different ways of finding new creative ideas. And I think it's going to be super useful. In case you are stuck somewhere or if you have any questions, you can always reach out to us on our Discord. And Saksham will be there in the Discord, and you can reach out to him on the Orcus at HTF channel, and he'll be more than happy to help you out with any of these queries, right? Apart from that, be ready for the Orcus challenge, as mentioned by Saksham already. For the winners, this swag pack to all the winning team members. I'm also excited for that. Saksham himself is going to be in person during the hackathon, so you can always reach out to him in person. There's a booth where you can reach out to them and ask all your queries. So, in case you haven't started exploring it already, get started right now. And this workshop is a good step for you to begin with, right? If you have any questions, feel free to drop them in the chat. If not, as I mentioned, you can always drop them on the Discord as well. But before we conclude this live stream, first of all, thank you so much for your time. Do you have any ending remarks for all our hackathon attendees and our community members?
Yeah, I have something. One thing I think, like use the Orcus playground effectively. You would like to know about the distributed systems, microservices. That would be useful for your future jobs as well. What Wherever you are going to work, like you will definitely work on something. If you are going to work on the back end, then definitely you will be working around with distributed systems and all. Then definitely you will be uh, going to learn about these things and all. So yeah, I would like to recommend that if you would like to contribute in open source project, then Conductor is a good option. You can read about it and probably dive deep into the Conductor. Yeah, that's all.
Awesome. Thank you so much for sharing that as well, Saksham. On that note, like everyone, thanks for joining. I mean, it has been fantastic one. And yeah, Saksham, I'll see you in person then.
Yeah, thank you.
Awesome. So, everyone, get ready. This was the last live stream for this particular season, and I'm quite looking forward to meet most of you who are joining in person for the hackathon, which is happening on 9 to 11th February in Gandhinagar. And hackers are joining in from across India, and I am way too excited for this. Can't wait totally. It's less than 2 weeks, I believe, and I'm sure this time shall pass super soon. But yeah, again, if there's anything you want me to help you with, feel free to reach out to us on Discord, open and organize a ticket, and we'll be more than happy to help you out there. But yeah, thank you so much for joining. I'll take a leave from here and I'll see you at the event itself. Bye bye. Take care.